And for the next we have product of vectors. Product of vectors is of two types. First is dot product or the scalar product. Dot product, or that is called scalar product also. This is written as A dot B, and it is the magnitude of A, magnitude of B, and cos of angle between them, and this gives the scalar quantity. So this is called the scalar product. We can also write it A B cos theta or B A cos theta. Again we have component of forces. If we draw the vectors to represent this thing, A B cos theta and B A cos theta, if we want to represent, explain this, we have these vectors. That is A vector, this is B vector at an angle theta. Let me draw this perpendicular O. Now this is B cos theta, and if we say that this is A vector, this is B vector, now we give the perpendicular from here theta, and this is A cos theta. Now what is this? This is the dot product of two vectors is magnitude of A, magnitude of B, and cos of angle between them. Or we can say A B cos theta means dot product of two vectors is the product of magnitude. Okay, so the dot product of two vectors, that is written as A dot B is equal to magnitude of A, magnitude of B, and cos of angle between them. It is also written as A B cos theta or B A cos theta. And if we represent these two vectors as, this is A vector, this is the B vector, and we draw the perpendicular here, so this is called B cos theta theta. And if we say that this is A vector, this is B vector, and we draw the perpendicular from here, then this is called A cos theta. So the dot product is also expressed as the product of magnitude of one vector and the component of second vector in the direction of first. This is also called the geometrical meaning of dot product, that in the geometrical meaning the dot product is the product of one vector, magnitude of one vector, and the component of the second vector in the direction of first vector. Now for the unit vectors, that is I dot I, J dot J, or K dot K. That is magnitude of 1, 1, and they are the parallel, means cos 0, that is 1. And but about I dot J, J dot K, and K dot I, now these are again the magnitude of 1, 1, but they are perpendicular, x, y, y, z, z, x, so cos 90 degree 0. Means now we have the conditions, two vectors are said to be perpendicular if their dot product is 0. Then how we get this is the condition, the two vectors are said to be perpendicular if their dot product, that is also called the scalar product, because it gives the resultant as a scalar. Now how we calculate the dot product? That is, as A vector is AXI cap, AYJ cap, and AZ k cap, and the B vector is, that is BXI cap, BYJ cap, and BZ k cap. Now when we find this A dot B, how we multiply this AX with all these coefficients, then AY with all these, then AZ with all these, but I dot I, J dot J, K dot K is 1, or baki another, the others which are perpendicular, they are 0. So how we get the dot product? That is AX BX, AY BY plus AZ BZ, because I dot I 1, J dot J 1, K dot K 1, but when it multiplied with this I dot j, that becomes 0. So no need to do that. Only just multiply the coefficients of these two, ax, bx, ay, by, az, bz. This will be give us the scalar quantity. So the dot product is called a scalar product also. Okay. Then next we have the vector product. Vector product, that is cross product. And vector product, this is a this gives a vector quantity. So this is represent as a cross b, that is the new vector c. Or how we write this? Magnitude of a, magnitude of b, and sine of angle between them. And this unit vector, we can write it as a n vector also. So, and this unit vector, that is, if we get the magnitude of this vector, this will become ab sine theta. Then it gives a vector quantity. So this is called a vector product. And how they read? A cross b. And if we have to find this perpendicular vector, that is written as a cross b divided by its magnitude. This is used to find the unit vector that is perpendicular to this cross product. Means a cross b and its magnitude give the unit vector in the direction of this vector product or a cross product. Now, how, if it is a vector quantity, then how the direction? Direction is given by right hand thumb rule. Thumb rule. That is, if we have this right hand and our curling of finger represents a cross b, then this point out the direction of c vector. And if we this b cross a, opposite direction. So if we say that this one, that is a vector, b vector, angle theta, and we say a cross b, then this is a c vector. And if we again have the two, a vector, b vector, and we say b cross a, then it will become the downward, that is the c dash. And c vector is opposite to the c dash vector. Means a cross b is not equal to b cross a, that is the opposite vector. But a dot b is equal to b dot a, because that is a scalar quantity. Now, for the unit vectors, the two parallel vectors, I cross I, j cross j, k cross k. And these two parallel vectors, how we write them? Magnitude 1, 1, parallel, so sine angle 0, and n cap. Sine 0 is 0, so 0. So what is the condition? That the two vectors are said to be parallel if their cross product is 0. Now how we calculate the cross product? We have the simple rule, I, j, k. I cross j, that will be, we write I cross j, give the third perpendicular vector, that is k. J cross k, that will be give the j cross k I. Now k cross I, that will be give the j. And if we write it opposite, j cross I, that is minus k, k cross j, that is minus I, and I cross k, that is minus j. So you just remember this. And opposite to give the negative of this, I cross j, that will be give k, j cross k, that will I, and k cross I, that will be give the j. Now, by this method we find the dot product, and this dot product gives the scalar quantity. Now how we calculate the cross product of these two? For finding the cross product, what we write? A cross b. Keep in mind the which vector is considered to be first, that is written first. जो पहला चाहिए वो पहले ही लिखना, पीछे नहीं कर देना, because otherwise it become the negative. So we draw like this, I, j, k, and I, j, k, and the coefficient ax, ay, az, and here bx, by, bz. Now how I write? First I say I cap. I cap. What is the I cap? That is j cross k. Means j cross k. means AY BZ minus AZ BY. Then J cap. Now what is the J cap? K cross I. K cross I. पहला A multiply होएगा. AZ BX minus AX BZ. Now the K cap. K cap is I cross J. So this is AX BY minus AY BX. So it means it's perpendicular. So it is also considered this perpendicular to the product of these two vectors, cross product. So it is also perpendicular because this is X, Y, Z. This is Y, Z, X, and this is Z, X, Y. So this is the method how we calculate the cross product of the two vectors, cross product. And this is the method how we calculate the dot product of two vectors. Okay, then for the next we have the resolution of vector. Resolution means resolve, splitting up for a single vector into the given directions of vector, and it is the reverse process of addition of vectors, and the vectors in which the given vector is resolved is called the components of the vectors. And if these components are perpendicular to each other, they are considering as a rectangular components. If we say that we have this vector R vector and it has to be resolved into two given directions, A direction and this B direction. So how we represent this? First we draw the vector OR, that is representing the R vector in given direction. Then we draw from the O a line parallel to this given direction, and the another line from this point R in given this direction. They both are intersecting at point P. Then this OR vector is represented as OP plus PR vector, and this OR vector, it is MA plus NB, means that direction should be given in the given vectors, but the magnitude of this may be MA plus NB, and a vector in given direction is resolved into the two components, and it will be have the unique value, means only one value. If we say that in the same direction these are the another set of values in which it resolve, then we when we equate them, MA vector plus NB vector, then M dash A vector plus N dash B vector, then how we write these? M minus M dash A vector is equal to N dash minus NB vector. But to prove this, to justify this, either the A vector or V vector should be zero vectors, but they are not the zero vectors. It means M minus M dash 0 या N minus N dash 0, or we can say M is equal to M dash or N dash is equal to N. Means a given vector when resolved in a given direction, it must be a unique value, it must be a unique pair. And if the vector is resolved, like this is a vector and it at angle theta, and it resolve into X and Y components along, and these two are perpendicular to each other, so they are called the rectangular components of the vector. And if we drop here the perpendicular, or one perpendicular here, and here we have a P, O, and here we say Q, then if its magnitude is X, because it is, we say that it is a position vector, its magnitude is Y. What is the direction? I cap, J cap. It means this OR vector is written as OP vector plus OQ vector if we use the parallelogram law. Then this R vector XI plus YJ, these are called the rectangular components, or we can say X square Y square square root. What is the cos theta here? X upon R. So X is r cos theta, and sin theta here y upon r, and y is called the r sin theta. So these are called the rectangular components of the vector. If we have the any vector form, this is the position vector. Let we have force vector. It has the two component fx, fy. This is called f cos theta. This is called f sin theta. So if the direction angle is along the x-axis, then in along the angle the component is cos theta, and opposite to this, because this is 90 minus theta, so it becomes the sin theta. Then these are called the rectangular components of the vector. And there are many examples which give this resolution, like the walking. When the man walk, it push the ground. We can say that it push the ground with the force, and the ground give the reaction force that will be at an angle theta. This reaction force is resolved into two components, cos theta and sin theta, and this sin theta that will be balance the weight of the person, this component, and it is helpful to move in forward directions. So the walking of a man on the ground is the example of the resolution of vectors. And one more very common example, that it is easier to pull a lawn roller than to push it. If we considering that we have this lawn roller position, and here the horizontal position, we pull it with the force F, angle theta, we pull this, and at angle theta, this is the weight of the lawn, and the component resolve cos theta and sin theta. So this component is responsible to pull, and if again this lawn roller is push, push kar liya si, to push this, again F force, that is the angle theta with horizontal, angle theta. Again it has the two component cos theta and sin theta weight. So here this sin theta decreases the effect of this weight with opposite direction, but here this component add with this weight and increasing the effect of it, and the same force is used to push or pull, so it is easier to pull than to push it. Then we have the relative velocity also, that is the relative motion. When the two bodies have the simultaneous motion, then the velocity of one with respect to the other is called the relative velocity. And finding the relative velocity, we have to superimpose, like this is a body, VA velocity. Now this is the B body. They are simultaneously parallel directions. We have to find the relative velocity of A with respect to V. We superimpose the velocity of B on both negative, so that this B come to rest, and here this negative decreases the magnitude because opposite. Then the two bodies, when they are moving in same direction, their relative velocity is a difference of their magnitude, because A opposite, A idhar, in the rest te aa jana, and either resultant cut jana. So keep in mind, when the two bodies are in a relative motion in same direction, their relative velocity is negative of their individual velocities. But if they are in opposite direction, and when you superimpose this opposite B, this is A, and now this is in this direction B, and this is B, and this is minus B, so it comes to rest. Now here the arrows are in same direction, means their magnitude is added. This negative is only just the direction, so in magnitude form this velocities, they are added. So keep in mind, when the two bodies have the motion in same direction, their relative velocity is negative, and when their directions are opposite, their velocities are positive. But if they are inclined direction, this is A, angle theta, and this is the B velocity. Now how to find the relative velocity with respect to B? Minus B, again I superimpose here the minus B. Now this will become the parallelogram side, and this is the resultant, that is called A with respect to B. And this is theta. Then what about this angle? 180 minus theta. So I have this resultant P square Q square plus 2PQ cos theta. So this is AB magnitude, and here A magnitude minus B, but it is a magnitude to this A vector, B vector, and cos 180 minus theta. And cos 180 minus theta is minus theta. So here I write A square plus minus magnitude B square minus 2A magnitude. This negative is compensating this magnitude, but this negative come from 180 minus theta. And when you want to find the direction, you have B negative sine 180 minus theta upon VA positive plus B negative cos 180 minus theta. Again, by using this we find the relative velocity. So this is about the product and the resolution of the vectors. Okay, thank you.